A particle P moves along the line OX. When its displacement from O is x meters, its acceleration is of magnitude 8 over x squared meters per second squared and directed towards O. Now we've discussed this one before. A is equal to negative 8 over x squared. We're now given that when x is 1, the velocity is 5, and we want to show the velocity of the particle tends to 3 as x tends to infinity. So v dv dx is negative 8 over x squared. So the integral of v dv is going to be negative the integral of 8x to the negative 2 dx. So this one's a half v squared, and this is going to be negative 8x to the negative 1 over negative 1 plus a constant. So a half v squared is going to be 8 over x plus a constant. X is 1, p is 5. So a half multiplied by 5 squared is equal to 8 plus c. So that gives me 12.5 is 8 plus c. So c is going to be 4.5 or 9 over 2. So a half v squared is equal to 8 over x plus 9 over 2, which gives us that v squared is equal to 16 over x plus 9. So, as x tends to infinity, what's going to happen is that this term here is going to tend to 0 because the x is dividing here. So as x tends to infinity, v squared tends to 9, which means that v tends to 3. So why did I decide that v tended to 3 and not negative 3? When x is 1, p is 5, so we know initially it's travelling in this direction. If we look at this expression here, if x is positive, this whole expression is positive. Well, we'd expect that with v squared, but we know that v squared can't be 0. There's no value of x here that would give us 0, no positive value of x that can give us 0. So it must continue to travel in a positive direction.